In this video, we're going to look at alcohols and ethers and how we can identify them and name them and draw their chemical structure. So we'll start with alcohols. So an alcohol is an organic compound that contains a hydroxyl group, which is the OH group. The general formula for an alcohol is ROH, where R represents an alkyl group. So what is an alkyl group? Well, it is a branch of carbons and hydrogens that's derived from an alkane by removing a hydrogen atom, and then that allows it to bond to something else. And we name alkyl groups by removing the ane from the name of the parent alkane and adding YL. So as an example, here's propane, a 3-carbon alkane. And if we remove a hydrogen so that it can bond to something else, we would then call it a propyl group. So when we're naming alcohols, we're changing the end of the parent alkane name to OL. Okay, so when you see that hydroxyl group, you're going to change the name and add an OL at the end. And if there's more than one location that the hydroxyl group could be, we indicate where it is with a number at the beginning of the name. So if we look at an example, so we see that hydroxyl groups, we know that this is an alcohol. So we count the number of carbons, and there are 6 of them, which means this is an alcohol that was derived from hexane. And so that's the parent alkane. And then we're going to add that OL on the end for the alcohol. So it's hexanol. So remove the E, add OL. And because that hydroxyl group could be on any one of those 6 carbons, we need to indicate which one. Remember, we always number the carbons so that whatever it is we're numbering has the lowest possible number. So we want to number it so that the OH has the lowest number. So we're going to number this one starting from the left, and that means the hydroxyl group is attached to carbon number 3. So we would then call this 3-hexanol. So now going the other way and drawing the alcohol when given the name, you're going to start by creating your carbon backbone of the appropriate length as indicated by the starting of your name. Then add the OH group at the correct location according to the number at the beginning of the name, and then fill in the rest of the bonds with H, making sure that each carbon has a total of 4 bonds. So let's look at an example, 2-butanol. So you see that name, the but, first of all, tells you that there are 4 carbons. So we start by making the backbone. Then we see that OL at the end, so that tells us it's an alcohol. And so the hydroxyl group is going to be on carbon 2. So we add that in, and then we fill everything else in with hydrogens so that every carbon has 4 bonds. So there we have 2-butanol. You can also give the structure using a condensed structural formula, right? So if we break that down a little bit, that first part has a C bonded to 3 H's, so that's CH3. Then we've got C bonded to an H and an OH, so we write that as CH and then OH in brackets. Then we have CH2, and then finally CH3. You can also give the molecular formula for this compound. Normally the OH is kept as OH, and the hydrogen that's part of the OH isn't added in with the other hydrogens, just because it gives you a sense of what type of molecule it is. So it would be C4H9OH. So now let's talk about ethers. So an ether is an organic compound that contains an oxygen atom bonded between 2 alkyl groups. So the general formula is ROR, where those R's represent the alkyl groups. So here's an example, right? We've got a hydrocarbon chain on each side of an oxygen, The oxygen in the middle is what tells us that this is an ether. So how do we name ethers? So what you want to do is start by identifying the two alkyl groups that are bonded to the oxygen atom. The smaller alkyl group, you're going to change the ending from ane to oxy, and then you're going to join that to the name of the larger alkane. So if we look at this example, so we want to identify the two alkyl groups. So we've got one on the left, one on the right. Okay, the smaller one on the left has 2 carbons, right? So that tells us it is F. And so it's based from ethane, but we're going to change the ending to oxy. So that's F-oxy. So that oxy kind of represents that oxygen that's stuck there. So it's F-oxy. And then the rest of the molecule is 3 carbons. So that's a propane. And so then we put those two things together. So this is F-oxypropane. And finally, how do we draw ethers when given the name? So you're going to create those 2 carbon backbones of the appropriate lengths, as indicated in the name, and then join them with an O. And then fill in all the rest of the bonds with hydrogen so that each carbon has a total of 4 bonds. So here's an example, propoxypentane. So the prop part at the beginning tells us that we have a carbon chain which has 3 carbons, and then the pent tells us the other side has 5, and then we need that oxygen in the middle. And then we're going to fill in all those hydrogens so that all our carbons have 4 bonds. And there we have propoxypentane. And again, we can also use the condensed structural formula because drawing all those H's gets a little bit cumbersome. So in this case, you just add the O in where it belongs. So CH3, CH2, CH2, O, and then CH2, etc. Or we can also give the molecular formula. So there are 8 carbons, 18 hydrogens, and that O. In this case, the molecular formula doesn't really tell us much about the structure, right? So that's when these structural formulas give us more information. So there you have how to name and draw alcohols and ethers.